So many of our energies are indirect solar energies, or energy that comes indirectly from the sun. Well, now we need to talk about energy that comes directly from the sun and how we use it. And we call that solar energy. There are two types of solar energy systems. One is passive, where you use no mechanical devices, and the other one is an active, where usually you're generating electricity either through a photovoltaic cell or through a power plant. And let's first look at the solar thermal power plants. Okay, what they do is they concentrate heat, all right, to generate electricity. Now there's many different ways, and you can see everything here on this slide, but if I go and show you, I think you'll have a better idea. You're looking basically at three systems, okay, that generate electricity, and what they do is they do the exact same thing a regular power plant would do, where you take water, turn it to steam, and that steam then would be used to turn a turbine. Except in this case, you're not burning anything to generate the heat, but rather concentrating the sun's light either onto a tube or into a tower or onto a particular receiver. Okay, and you concentrate the light. That light provides the heat, and the energy then is used to turn water into steam. All right, so the first type here, as you see, are long rows of tubes, and if you look closely, you will actually be able to see that some of the tubes, or the tubes in the along the mirrors, right there, have water going through them. Sunlight comes down, hits the mirror, bounces off, and focuses directly onto that tube, and that focus then heats up the water. And as you can see, if it travels through numerous pipes over a long distance, you're going to be able to create a lot of hot water, and that water then is converted into steam. The steam then would turn a turbine and generate electricity. So a pretty basic idea. All right, this one's a little bit different, where instead of focusing the light on a tube, here you're focusing it on a tower. So you have a whole bunch of mirrors that rotate with the sun, all right, so that no matter what time of day it is, the sunlight will hit those mirrors and focus the light onto the one tower that you see there. These mirrors that rotate with the sun are called heliostats. And those heliostats direct the light to the tower, where water can be pumped into that tower, and that tower then can produce huge amounts of steam, because with a large array like this, the heliostats produce or reflect a lot of light to that tower, producing a huge amount of heat, consequently creating a huge amount of steam. And here's another picture of another one. You can see the tower there off in the distance. This is the tubes, like on the first one I showed you. Here's the tower system. Now, they improved the tower system by adding in a storage for the heat, and that is salt. And what now happens is, as the sunlight comes down, hits the heliostat, okay, focuses on the receiver, instead of pumping water in it, they pump salt. And the salt then is pumped up, gets superheated, all right, comes down, and this is usually underground. It goes into a hot storage tank. Okay, so now you have super hot salt, which you then can, through a series of pipes, run water through it, through pipes, and now the water turns into steam, all right, which then can be used to run a turbine and then create electricity. So the great thing about the salt is that during the day, the sun energy could be stored in that salt, and that salt should remain hot enough through most of the night where you can continue to make electricity all night long. So this is a solar thermal power plant able to produce electricity 24 hours a day. Where is solar energy good for America? It's pretty much concentrated in the desert southwest of the United States. If you go to the East Coast, although we do have some limited solar, it's just there's not as much solar energy available for any type of solar power system. So most of this technology you're going to see in the desert southwest, because that's the best place. Worldwide, you can see here, United States in the desert southwest, but across Africa and the Middle East and Australia and even throughout China, you have some potential to use this around the world. And that's good news, because a lot of these places are third world countries where the developing nations just cannot produce their own power. So if we want to have them, if we want to prevent them from going to coal or oil, then we can supply them with solar panels or solar technology to create the energy that they need. And that will make them jump the fossil fuel stage and go directly into the renewable stage, which would help the climate throughout the world. All right, second type is photovoltaics. Photovoltaics is where you actually make electricity. This is active solar. And the process is quite simple. Solar panels are made up of silicon. The silicon then has two layers, the N layer, which is the top layer, which you see right here, and then the P layer, which is the lower layer. And then between the two, okay, you have what they call a junction layer, okay, and that's going to become very important. So when sunlight now hits the solar panel, what happens is, if I just take that idea and jump down to this lower circle here, when the light hits the silicon at the top of the junction, the electrons are stripped off the atoms. Okay, so the electrons are, unfortunately, not unfortunately, but created so that they float on the surface of the solar panel. So you have a whole bunch of electrons up on the surface. They are stripped away from the nucleus. Then the lower layer, what's sometimes called the hole, the P layer at the bottom, the electrons from the P layer jump up and fill in for the electrons that left up here. All right, so this is a one-way transfer of electrons coming up. But then what happens is, as those electrons get transferred up, you now end up with a net positive charge down here because you lost the negative charge of the electrons. So how can you neutralize that? Well, it's very simple. Here are the negative charges. All we need to do is take a wire and connect it to the bottom layer, allowing a conductor to transport these electrons from one side of the solar cell to the other. They can then fill in and neutralize this area. Now you've got it neutralized, but then this process continues. As more sunlight hits it, more electrons jump. Therefore, more electrons come up from the lower level, and which means there's now more of a net positive charge. So more electrons continue to flow, and you keep this process going as long as there's sunlight. So hopefully that gives you a basic idea in that mess that I drew. Again, it's very simple. Just to make sure you understand, light hits the solar panel, you end up with freed up electrons. Those freed up electrons will go down conductors across your solar panel here, all right, and head to a wire, because as those electrons jump up, electrons from the lower level jump up to replace them as they leave, which gives the bottom layer a net positive charge, therefore called the P layer. That net positive charge can be neutralized by having the electrons leave the upper layer through a wire, which is what we call electricity, so it can be used, down to the lower layer where they can now neutralize that net positive charge. And then as more sunlight hits, the electrons then continue to jump, and they end up on the surface. And then the same thing happens, they lower level ones jump up, and it continues. All right, hopefully that gives you a good perspective on how this works. And if not, you can take a look at some of the pictures and go back and review. Here's another diagram of the same thing. But now we have a way to make electricity using just the sun. And we can put them on houses and on yards, and you can put them almost anywhere. There's all types of flexible solar cells. A lot of times you see these on streets, on lamp posts, where they're charging emergency lights, or it might be traffic signals and things like that. And we also have new technology that makes solar cells even more efficient. A theoretical limit to the efficiency of a solar cell is about 33%. Actually about 33.666 or 33.67%. And that's the theoretical limit on the efficiency of a photovoltaic cell. Now, new technology has come out that we think we can take that theoretical limit and not only surpass it, but surpass it maybe 3 times, meaning that our efficiency can go up to 80 or 90%. And that's a new process that's here. We're not going to get into it. It's using nanotechnology. The information's here if you want to go back and take a look at it at some point. All right. There's a good explanation that you can use as you go through the process here. Okay? But that's more for you to look at, and feel free to take a look at it on your own. For us here today, that's not that important. If you go over to the connections building, you'll see our solar panels are producing electricity for the solar panels. Our system is about a 4 kilowatt system. It's actually 3.5 kilowatt. That's our maximum potential for creating electricity. That electricity then goes into the building and we use it for that. Now, we also have these systems called off-grid, where the solar panels or the photovoltaic cells will charge a bank of batteries, which will then run your house. Now, the problem is that means your house or building must run off of DC electricity, not AC electricity, because DC or direct current electricity is the type you get from batteries. And that's not what our appliances and stuff run off of. They run off of AC. So how does this whole system work? Okay, this is a quick review. Sunlight hits the solar panel produces electricity. Electricity through the solar panel has to first go through a controller. The purpose of a controller is to keep the charge steady. So as the sun goes in and out of clouds, okay, the charge doesn't keep going up and down, up and down. It sort of makes a more even charge, which is what you need, obviously, to run your appliances. Then you can send that into a battery. And then you can use the battery at any point and use it for whatever you want, but it must be DC electricity. So it must be something that runs off of batteries. Or you can take the electricity from the controller, skip the battery, and go right into an inverter, which then takes the electricity that comes off of your solar panel, which is, by the way, DC, direct current electricity, and through the controller into the inverter. The inverter then makes it into alternating current, or AC, which is what most households use, and then that can go into your home to be used. Okay? That's how the system basically works. Nothing too complicated. And it's a possibility for us to use them in our homes, but we have a system we have to put together for it. Now, some places aren't off-grid, where they would just have the batteries. If you want to, you can hook up your solar panels to your regular grid that comes into your house. So again, the electricity, sun hits the panels, sends the electricity to the inverter. All right, the inverter then will send it through as AC current into your house to be used for whatever you want to use it for. Or if you don't need it in your house, in other words, it's making more electricity than you actually need, net metering means it'll go back, all right, through your meter, make it spin the opposite direction, meaning that the electric company is going to see you actually producing electricity, not using it, and then send it back into the grid system, where someone else down the wire can use the electricity. So net metering means you're hooked up to the regular grid, like normal, but if you want, you make so much electricity, instead of using it in your house, you send it back into the grid. That's called net metering. If you're off grid, you put all your electricity into a battery bank and where it's stored for you to use. But if you're with the grid, whatever you can use, you use. If you can't use it, you send it back into the utility lines. So just another option for families to use. And the last thing is passive solar hot water systems for a house. Okay, here's what it's not the same as using solar energy for hot water for making electricity, but in this case you're just making hot water for your house, called domestic hot water. Very simple idea. Okay, you put a panel on the roof. There's 2 different types. Usually a flat plate collector is the most common over here, and it's very, very simple. Sunlight hits the solar cell, the solar panel. Okay, the panel is just basically glass on top. Then this inside here is black metal with black pipes running through it, and you bring water in to make it run through this metal. As it goes through, the metal is very, very hot from being out in the sun. All right, it's well insulated, and what you have coming out is hot water. That hot water then can be sent down to your home to be used either as a way of heating up your water or directly of water. A batch collector is the same type of thing, but in a batch collector, okay, you actually have a large amount of water sitting in your collector. All right, and as it gets hot, you then send it back down. So you would take the cold water, pump it in, let it sit, get hot, all right, and then you send it right down into your tank, and then you would pull it off for your shower. So this system is one which actually you use the water that goes up on your roof. The more common, the flat plate collector, usually you would send water with a little bit of glycol in it, all right, and that glycol will keep it from freezing, all right, but that means you can't use it, you can't drink it or anything, and you can't obviously use it as a shower or anything like that, but it keeps it from freezing, so, and to keep it from boiling it too much. But the glycol itself then provides the ability to protect your system, and then you can just use your system to bring in hot water in through pipes and let the cold water come in contact with those hot pipes, which will then heat it up in what they call a heat exchanger. It's very simple process that generates a fair amount of energy, and then you use it through your hot water system in your house. So hopefully that makes a little bit of sense. All right, it's just a passive solar system for hot water for your house. This is a better picture of the flat plate collector, where these are the exact same ones we have over at the Connections building. Sunlight hits, okay, heats up the water as it's traveling through these pipes. Okay, it's well insulated with a good layer of insulation underneath, glass on top to keep the heat in. All right, out comes hot water. When the hot water comes out of the pipe, it'll go into the heat exchanger, which is a tank inside your house. This pipe will just coil through like this and then come out and somehow come all the way around here if I can make it and go back in. Then what you do is you send in with your house water into that tank, and the water sits in here and comes in contact with that hot pipe, and that water gets very, very hot, and then you send that hot water over to your sink and shower. Okay, flat plate collector system for your home. So that pretty much takes a look at solar energy that's we can use. Gives you a better perspective on how the sun is being used. It's still in its infancy. We still have a lot to learn. We're hoping to increase this efficiency of photovoltaics and maybe come up with new technologies. Excuse me. The growth is there. It is predicted that we will have an over 1,000% growth rate in the use of electricity in the next 20 years, next 10 to 15 years. And so tremendous potential. And let's just hope that someday we'll use that potential and we will see solar become a normal part of our everyday energy system. Thank you.